This lesson video is reviewing Chapter 7, Lesson 5, parts of similar triangles. So we've been talking in this whole Chapter 7 about proportions and similarity, right? And in 7-3, I believe, we talked about similar triangles. So taking a triangle and either enlarging it or shrinking it, but proportionally. So we don't really change the shape of the triangle, we just change how big or how small it is, right? And then we skipped a little bit around in Lesson 7-4 to proportional parts, right, of triangles and when you have parallel lines and transversals. And now we're going back to our triangles, our similar triangles. So if you've got two similar triangles, if they're proportional, right? This guy, basically we just took it and shrunk it proportionally to get this guy. So when you have proportional triangles, all of the corresponding parts are also equally proportional or proportionate. So if this triangle is proportional to this guy, it's obviously bigger, but proportionally, that means the ratio of this to this is the same as the ratio of this line right here to this line right here, right? All the corresponding parts are proportional. So we could say 24 over x, just write a ratio, and that would be equal to, this to this would be equal to the length of this compared to the length of this, which is 10 to 8. And then if we wanted to solve for the missing piece, to solve for the length of this, we would just cross multiply. So 10x equals, and then 24 times 8, 20 times 8 is 160, 4 times 8 is 32, so 192. And then I would divide by 10, and x equals 19.2. I wouldn't necessarily give you a decimal. I don't like to use decimals unless the problem does. However, when they solved here, they did go ahead and simplify to a decimal. I would have just simplified and kept it in fraction form myself. But they got 19.2. So if this is 24 and this is 10, and this triangle is proportional, then this would have to be 19.2 if this is 8 for it to be proportional to this. Okay, so we're just going to do some example problems, kind of keeping that in mind. All right, so for all of these exercises we're about to do, there's 6 of them. They're proportional triangles. So when we compare corresponding parts, they're all going to be proportional. Okay, so in this triangle, it's obviously bigger than this guy. These 2 pieces are equal, and these little 2 pieces are equal. So, and this angle is marked congruent to this guy. This angle is marked congruent. Remember, in triangles, the angles can be congruent, but the length of the sides don't necessarily have to be congruent. They just have to be proportional. Okay, so if we write a ratio of this to this, so if I wrote 36 to 18, that should be the same as the ratio of this to this, 22x. And we can go ahead and cross multiply, that's fine, but remember what I said, I think in the last video, about simplifying your fraction first instead of at the end. If we cross multiply here, we're going to have big numbers. If I go ahead and just, I can't simplify this fraction, but I can simplify this guy. 36 over 18 is the same as 2 over 1. So I'm going to go ahead and change that to 2 over 1, and now I can cross multiply and my numbers will be smaller. So 2 times x is 2x, 1 times 20 is 20, and then I can just divide, and x is going to equal 10. That's a lot quicker than getting 36 times x equals 18 times 20. All right, number 2. Again, we've got proportional triangles, so all their corresponding parts are proportional. So 12, the relationship between this side and this side, 12 and x, will be equal to the relationship between this angle bisector and this angle bisector. I know it's an angle bisector because it's a line cutting through this angle, and it cuts it into 2 smaller congruent angles, and it does the same thing here. Okay, so this line and this line have the same relationship. 12 to x is the same as 9 to 6. And then before I go ahead and cross multiply, can I simplify? Yes, I can simplify this fraction to 3 over 2. So 12 times 2 is the same as x times 3, or is equal to x times 3, 3x. And then I can divide both sides by 3. 24 divided by 3 is 8. So x will equal 8. Okay, number 3. I've got these two proportional or proportionate similar triangles, right? So their corresponding parts are also proportional. This side to this side, I'll say 4 to 3 is going to be equal to this to this, 3 to x. So I'm going to cross multiply. And I get 9 equals 4x. Divide by 4, divide by 4. X equals 9 over 4, which if I simplify that fraction, it's improper. 4 goes into 9 2 times, and I have 1 left over. So x is equal to 2 1/4. I did not use my calculator, and I did not get 2.25. I got 2 1/4. Okay, number 4. All right, here they did something interesting because they had these two just normal triangles that we could have used, but they went ahead and kind of made these imaginary, they extended these lines and created this kind of imaginary triangle here on the tip. But since these triangles are similar, proportional, then if they created this little right triangle here, they did the same exact thing. They created a right triangle here, so these should also be proportional, right? We're doing the same thing. Hopefully you get the kind of pattern going on here. When you're doing the same thing to the triangles, you're going to have equal ratios. They're proportional. So 10 to 8 should be the same as 10 to 8, which should be the same as x to 7. So I'm going to write x over 7 equals 10 over 8. And I can simplify. 10 over 8 is the same thing as 5 over 4. So then when I cross multiply, x times 4 is 4x. 7 times 5 is 35. And I get x equals 4 goes in, oh, sorry, I didn't realize you can see that. 4 goes into 35. Not evenly, but 4 goes into 32 evenly. That's 8. And 35 minus 32 gives us a remainder of 3. So 8 3/4 for that one. If you guys want to go over in the live conference, if you want to go over simplifying fractions, we can do that too. Okay, 2 more. Number 5 and then 6. Number 5, here we have two proportional or two similar triangles. Be careful here because one has been flipped and rotated, excuse me. So you want to make sure that you're paying attention to what the correct corresponding sides are. Okay, so here it has this angle marked the same as this. So I can tell that this has been flipped over and then flipped over, right? So this guy is corresponding to this guy. This side's corresponding to this side. This long side's corresponding to this long side. So just keep track of that. All right, so this bottom 45 has a relationship with this guy, which was the bottom until we flipped it and flipped it, right? So that's 30. And so that's equal to the length of this altitude and this altitude. Remember, the altitude of a triangle is the height, right? From the base to the highest point. From the base here to the highest point, and the base to the lowest point here because it got flipped upside down. All right, so now before I cross multiply, I want to simplify. I can't simplify this because I don't know what x is, but I can simplify this. I can divide the top and the bottom by 15, and so then I get 3 over 2. So I'm going to cross multiply this guy, cross multiply this guy. 2 times 42 is 84. 3 times x is 3x. And then divide by 3. 3 goes into 84 28 times. So I should write x equals 28. 28 equals x, or x equals 28. You can use a calculator on this. I just do not want decimals unless there's a decimal in the problem. If there's no decimal in the problem and your answer is something that's not a whole number, then you should have a fraction. I want to see the work you did. Don't forget to get full credit on your work. You got to show all of it. All right, and then lastly, number 6 here, we've got these two triangles. They're similar, so we have to compare corresponding parts, but they've made it difficult because they flipped it and then they flipped it, right? Or actually, they didn't flip it upside. They just flipped it upside down. That was it. So if these two sides are equal, one of these is the same, has a ratio or relationship to one of these, right? They're the same, so it doesn't matter which is which. So 12 over x equals, and then the height is the has a ratio to the height, right? We can write a ratio of the heights. So this segment and this segment have a ratio. This height and this height have a ratio. 12 over 14. Okay, and then before I cross multiply, can I simplify it all? Yes, I can simplify 12 over 14 to 6 over 7. And then I can cross multiply. All right, so x times 6 equals 12 times 7. And then I can divide by 6. X equals 6 goes into 84 14 times. Okay, any questions? Let me know and look out for part 2 of this lesson.